Welcome to Solid State Physics course. So I'm Dr. Santosh Kumar Alla. So in previous class, we discussed about the importance of ECE, Electronics Communication Engineering, and also we have seen the units. And unit 1 is basically consists of interference. So basically all these units are mainly waves. Now, for that, first we have to have knowledge on what is wave. By looking this image here, in plain water, if somebody is swimming, then waves are created. So that's why we say it is a wave. And also the small droplets which disturb the water, so waves are formed. And this is one type of stereograph. In music stereos, there some oscillating something, that also we say it is a wave. And here it's a small dancing, so it is form kind of a wave they are making. From these examples, we can define wave is a disturbance created in the medium. So these waves which are carry energy from its source to another location. But the condition is there is no transformation of particles from one place to another place. That is a wave. Here, by looking at this duct is never translated in energy. So energy is translating from this place to, it is going like this in this direction. But duct doesn't move in this direction. It's simply going up and again coming back. So that means the neither of any particles in this medium getting translated in this direction. So this is what is called wave. Now, the same thing if you observe the particles in a medium, let assume it is moving upward and upward. These are interconnected. So by moving up and down directions, let's say you only concentrate on first particle, this one, and it is doing one oscillation. Now, because of doing one oscillation, then if you see what about the remaining particles, these remaining particles are in the positions. If you connect all the positions, if you connect all these positions, then it look like a shape of wave is coming like this. That means it is doing from up and downward direction, moving up and down, then one wave shape is coming. So the locus of disturbance created by the first particle, the particle displacements in the other particle displacement, if you connect all these things, that is form of the wave that we can see. And now, types of waves. What are different types of waves? Longitudinal waves. If the direction of vibration of particles in the same direction of propagation of wave, that is called longitudinal waves. So in longitudinal waves, see, let's say example A, all the particles in the uniformly distributed, as set an example. Whenever if the longitudinal wave is there, means the density of the particles here is very less, the density is more. Density of high, lowest, and high. Like this, compressions, rarefactions will form. So the midpoint of this rarefaction is take it as a this one wave shape. You can represent like this downward, that negative amplitude. The density is very high here, that represent midpoint represent with the maximum displacement, that is called amplitude. So this is the top amplitude, positive amplitude represent with the compression midpoint, and negative amplitude represent with the midpoint of rarefaction. So example longitudinal waves is sound waves. How sound waves will travel and how longitudinal waves are created. See this hand moving forward and backward direction, this oscillation. Because of moving and forward, the compression of spring is taking place and compression of expansion of spring taking place. You can see in this image clearly. So compression and again expansion, compression, expansion. Then how we can correlate with the medium? In the medium, so these are all we can see. So we can see here this in this it is like a piston. You assume these are the air molecules inside because of the suddenly it is moving. The density of particles are more. In this area, density of particles less. It is moving continuously oscillating with some time period. Based on that, compressions and rarefactions are formed. The similar thing we can say compression, we can say maximum amplitude, positive amplitude. Rarefaction, we take it as a this one. The distance between two rarefactions or two compressions should be lambda. So this is what we can demonstrate by using this one. And next, transverse waves. The direction of vibration of particles is perpendicular to the direction of propagation of waves. Such waves is called transverse waves. In transverse waves, this we can say it is a crust, maximum amplitude is crust, positive amplitude, negative amplitude say it is a trough. Crust and trough we can see in the transverse wave. Example, light waves. Also, if you one rope, if you take one end is connected, so one is you are oscillating like this in a rope, then automatically the waves, transverse waves created in the rope. And also here we can observe the person who is sitting at the last, how he is moving up and down, that oscillation he is doing. Based on the oscillation, everyone is doing it with a particular time period, then we can see the wave beautifully. This is about transverse waves. Why in this case, the oscillations are which direction? In this direction. Oscillation of in this direction, wave propagated in this direction. So both are perpendicular. Whereas in case of longitudinal waves, the oscillations which are doing in this direction, wave is also propagating in this direction. The oscillation of the hand is same direction. The wave propagation is also same direction. Here also this piston is oscillating in this direction. Wave is also progressing same direction. Whereas in case of transverse waves, the oscillation wave propagating in this direction, but oscillation is vertical direction. That is, these two are perpendicular. So this is what transverse waves. So this is the difference between spring oscillating the same direction of wave, but here spring oscillating perpendicular to the propagation of wave. And standing waves. Standing waves is combination of two waves which are traveling in opposite direction, and both waves will have same amplitude and frequency. It is like this. Again, it is going here. Here there is something stopped is there. Again, it is reflect back. The reflection will occur. Again, it is coming here. Again, it is going. So like this, it is a wave. It is in between 2 points. The wave should be remain. This is also called stationary waves. Here, stationary waves maximum amplitude called antinode. Zero amplitude is called zero displacement is called node. Maximum displacement, that means maximum displacement is antinode. Minimum displacement is node. So nodes, antinodes will form in standing waves. So these are about the waves, standing waves that we can see in our lab also. We can demonstrate how waves are here. See, coming wave is coming here. It is wave tag, so it is reflect back again like this. So based on how the what is the frequency, we can make it into either one oscillations or more. See here one node, another three nodes, four nodes. So like this, we can create the nodes, antinodes more based on the by changing the frequency. So these are the different waves. So far we discussed longitudinal, transverse, and standing waves. So these are different shapes of the waves: square shape, triangular shape, shortwave shape. Okay. So we will discuss in detail about the waves in the next class. Thank you.